For our senior design project, we designed and fabricated a prototype magnetic bearing. Our main objective was to create a system which would float without friction beneath a steel plate. The bearing needed to be self-contained, battery-powered, and controlled wirelessly. The bearing supports two modes, a lock mode and a float mode. In lock mode, the bearing is firmly attached to the steel plate. In float mode, the bearing floats an adjustable distance beneath that steel plate. The key component to the bearing is the TIVA microcontroller. 1,000 times per second, it samples the voltage across the three infrared distance sensors, each mounted 3 mm below a magnet. The sensors are calibrated each time the device starts, so the bearing is insensitive to changes in the steel plate. The TIVA uses the voltage from the distance sensor to calculate the distance between the corresponding magnet and the steel plate. Using a PID controller, the TIVA then uses this information to determine the current the magnet requires to maintain the desired distance between the magnet and the steel plate. Once the TIVA has calculated the current required to maintain the set floating distance, it converts the current to a duty cycle used in a PWM. The PWM output of the TIVA is fed into a low-pass filter, which in turn controls the onboard power electronics. An op-amp adjusts the current output by a MOSFET until the voltage across the sense resistor is equal to the voltage coming from the low-pass filter. The resulting current through the sense resistor is equal to the current through the magnet, corresponding to the necessary current calculated by the TIVA. Just below the TIVA is an HC05 Bluetooth module. This module allows for wireless control of the device using either the PC or Android app we developed. The device can be switched between float and lock mode, the float height can be adjusted, and the magnets can be all shut off. When transitioning to lock mode, the device continues using the PID controller for 100 milliseconds to get the bearing close to the plate. A constant current of 200 milliamps is then fed to each magnet to lock down, and the current is decreased to a steady 130 milliamps after 50 milliseconds. Underneath the device are two 11.1 volt, 750 milliamp hour batteries connected in series. These lightweight lithium-ion batteries are not only rechargeable and lightweight, but they are enough to power the device floating 0.6 millimeters from the plate for up to 55 minutes.